Hi, in this video, we're going to continue our example on piecewise defined function. So the next example will be this one. Function g we defined by g of x equals 3x minus 2 if your x is less than 1, or g of x is equal to x squared if your x is greater than or equal to 1. So remember, we have a boundary here of 1. So we're going to draw this. So as our guide. And then we're going to first graph this function g defined by g of x equals 3x minus 2. Remember, we're going to consider x which are less than 1. So all of the numbers here except for 1. So 1 is not included. So expect that this one is a line because that's a linear function. G now in that case is a linear function. So we'll first use g of x equals 3x minus 2 if your x is less than 1. So since that's a line, we need only 2 points. Now I suggest that you pick a point in the boundary and pick another point somewhere in the that is in the domain of our or yeah, in our function g. So let's say I pick first 1. Okay, so I let x be equal to 1, then g of 1 is minus 2, so that is 3 minus 2, so that's 1. So if your x is 1, your g of 1 or g of x is 1. So we have 1, 1. So we have 1 point. And select another point. Okay, and then choose x somewhere in this domain. So let's say I chose 0 to make it simple. So I let x be equal to 0 and then substitute. So that is 0 minus 2, that's negative 2. So if x is 0, your g of x is negative 2. So we have 0, negative 2. So I plot this 2 points. Okay, 1, 1. Okay, 1, 1. It's here, but I only use hollow because 1 is not part of the domain. Okay, because there is no equals there. So it's not x is less than or equal to 1. It's only less. So which means to say that this point is not included in our line later. Next is 0, negative 2. So 0, negative 2, it's here. So it's here. So you use now a solid because we're getting the x that is part of the domain of our function g defined by this. Okay, so now let's connect the points using a line because this is a linear function. Okay, so we already have a graph of the g defined by this. So we've already graphed that one. This one is, it's not linear because this is quadratic function. So this time it's quadratic. So remember the quadratic. So this is only if your x is if your x is greater than or equal to 1, right? Sorry. So remember the graph of x squared. Remember the graph of x squared? The graph of x squared is actually, if the domain is all real number, then the graph of x squared is this. Since we're only considering all those values of x that are greater than or equal to 1, so we're going to graph this part only of the graph. So we will erase this part and then graph this part only. Okay? So to do that, we are expecting a graph that looks like this, yes? Okay. But we're going to cut this one, so let's graph this part only, since we're considering only x's that are greater than or equal to 1. So it's wise to start here so that we may know. So let's start here so that we may know somewhere in this in this 1, x equals 1, so that we may know where to start graphing first. Okay. So I let x be equal to 1. So of course we have to substitute. So that's 1 squared, so 1. So if x is 1, your g of x is also 1. So 1, 1. Alright? So 1, 1. So 1, 1. 1, 1 is here, right? It's here. Okay, this hollow itself. So this one right here. So we will use the solid now. Solid point, because 1 is included in our domain. Alright? That's equal to, so which means 1 is already included in our domain. So meaning you start from here and then you draw something like this. So curve, right? So since this is the graph of x squared, if your domain is all real numbers, since we are only considering all those numbers from 1, including 1, up to positive infinity, so we are only to consider this part of the graph. So let's erase this one. So now the graph, the appearance looks like this. It's a curve. It's not a line. Okay, it's a curve. So something that is part of this curve. So now we already have a graph of G. So this one in combination, so collectively this is known, this is the graph of our G defined by these two expressions. And so we are done. So now this is the graph. So the key here is that we should be familiar with how do we graph, or you should be familiar with the method on how to graph simple functions manually. So you have to review first the linear function, how do you graph that one, and as well as the quadratic function, and then you review also the translation of graphs that may be important later. So that would be all for this example. Thank you very much, and have a nice day.